Okay, so well, let's kind of talk about a shortcut for geometric sequences. On this example, we're talking about cells, okay? On this particular, let's see, cells, uh, there's what we call a mother cell that divides itself into two daughter cells. Then each of those daughter cells then divides itself into two more daughter, and so on. So they've given us this sequence right here of 1, 2, 4, 8, 16. Now, we start off with a mother cell of 1, get two daughters from a cell division, and then another cell division happen, we get 4. And what we're happening there is, let's have a geometric sequence. And the reason why it's geometric is because we are multiplying by a common ratio of 2. So mother cells is in the petri dish, then it has division, and we get two daughter cells. A division, and those two daughter cells create 4 daughter cells. And then keep going like that, okay? Each division creates 2 times the amount. And the same thing is happening in terms of our terms. They're always 1 off, okay? It's always 1 more because we have that mother cell before any cell divisions happened. So if we continue down that road, keep multiplying by 2, okay, 512. We're going to end up with 512 cells after 9 divisions. Now, just like we did on RICO, we can continue doing that for the 10th division and the 11th division and so on. But that is going to get a pretty big table quickly when you want to calculate something way down the road. Now, what we were doing right here is what we call a recursive formula. We kept multiplying the previous term by 2. So that's what the next page briefly talks about, is that we have a recursive formula, take the previous term, keep multiplying by 2, which is great. That's what we've been doing. But now, if we want to calculate something like the 40th term, that's where we want to bring in what we say is our explicit formula. So this is our geometric explicit formula that you want to add into library with your arithmetic one. So on the worked example that they have here, if you want to calculate the 20th term, got to know what your starting term is, which is 1 because there's 1 mother cell, and then you got to know what the common ratio was. In this case, we were creating 2 daughter cells for each division, so times 2. We use that now equation to help us find the term. So to get the 20th term, I plug in 20 minus 1 for n, and I go to my calculator and I punch in 1 times 2 to the 19th. 2 to the 19th is a pretty large number. Times it by 1, it gives you itself. So after on the 20th term then, we have 524,288 cells. And that means we had 19 cell divisions happening. So let's do that now ourselves, just like we did on the previous page. If I want to do 11 divisions, what technically that was talking about is the 12th term. Now, for this particular problem, we are using that formula, that explicit formula. This is our guy, where G sub 12 is going to be 1 times 2 to the 12 minus 1. Go to your calculator and just punch it in. Let's punch in 2 to the 11th times 1. Go punch it in, 2,048 cells. On the 14th division, we're talking about technically the 15th term. 1 times 2 to the 15 minus 1. That means we have 14 cell divisions, 2 to the 14th, plug it into your calculator, times 1, and that gives me 16,384 cells. Okay, this is technically talking about the 19th term. So I keep doing this the same idea. That means 18 cell divisions. Go to your calculator, punch it in. 262,144 cells. And the last one then. Okay, after 22 cell divisions, plug it into your calculator. I'm up to 4,194,304 cells. Okay. Now, with that in mind, same thing kind of happened. We're going to change it up. This was our original equation. And then we have a change up here with another type of scientist, where we now have 5 mother cells instead of 1. And she's wondering if those mother cells divide into 3 additional cells instead of 2. So we're going to change up our equation, where 5 is my starting number, and then 3 is going to be my common ratio. And that's what number 4 is essentially doing, where we have our term and then our value, which is going to be the number of cells. So we're starting off with 5 cells, and then it triples. So we have 15 after a cell division. We have 45. We have 135. We have 405. All I'm doing is multiplying by 3. That's my use of what we call a recursive formula. But now when I want to calculate this way down the road for 13 divisions, let's use my explicit formula now. Okay, so here we're talking about the 14th term. 5, we're using our new one. 13 cell divisions times the original 5, and we get a very large number very quick, 7,971,615 cells. Quite a bit of cells. And for the last one here, same idea. 16 cell divisions times that 5, 215,233,605 cells. Okay, we'll continue on with the next